What if your AI could do math for you with perfect accuracy every time? You'll see how to create a simple calculator tool that AI models can call using just a few lines of Python with FastMCP. The pattern shows how to expose any Python function as an AI-callable tool, complete with type safety and automatic documentation. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals calculator server. At MCP, tool. Def add a int b, int. Adds two integer numbers together. Return a plus b. This demonstrates the AI tool integration pattern, where Python functions become directly callable by language models through a standardized interface. The decorator approach transforms regular functions into AI-accessible tools while preserving their native Python behavior, creating a seamless bridge between code and AI capabilities. What makes this distinctive is its ability to maintain clean separation between business logic and AI integration concerns. The pattern works by leveraging Python's decorator system to declare tool capabilities declaratively. FastMCP automatically introspects the function signature, extracting type information, documentation, and parameter details to generate a complete tool schema for the AI client. This metadata-driven approach means your implementation stays focused on core logic, while the framework handles all serialization, validation, and protocol communication. This approach solves the critical problem of AI system integration complexity. By eliminating manual API boilerplate and protocol handling, developers can expose backend capabilities to AI systems with minimal overhead. The pattern is particularly valuable for creating modular AI assistants, where you need to dynamically expose various backend services without tight coupling to any specific AI framework or transport protocol. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It transforms Python functions into structured APIs that AI models can invoke directly, handling serialization and type validation automatically. MCP equals FastMCP. Name equals calculator server. This instantiates the FastMCP server with the identifier calculator server. The name parameter uniquely identifies this toolset when multiple services are running, enabling AI models to target specific tool collections. At MCP, tool. Def add a int b, int. Adds two integer numbers together. The @MCP tool decorator registers this function as an AI-callable tool. FastMCP uses the type hints and docstring to auto-generate the tool's schema, ensuring proper input validation and documentation. This is the core pattern for exposing Python functions to AI models. The decorator handles serialization, error reporting, and progress tracking automatically. Return a plus b. This implements the actual addition operation that fulfills the tool's contract. The return statement delivers the computed result back to the AI caller, completing the tool execution cycle. Simple arithmetic here, but the pattern scales to any deterministic computation. FastMCP tool registration. The @MCP tool decorator transforms Python functions into AI-callable tools with automatic schema generation, where type hints become JSON validation rules and docstrings become natural language descriptions. Tool names default to function names, but can be overridden in MCP config, creating a separation between code identifiers and protocol contracts. This pattern eliminates boilerplate while maintaining strict type safety across the AI interface.
The decorator that writes no schema validates every call